So today's training will be on ZigBee Wireless data acquisition. We will start with a brief introduction and then I'll introduce wireless technology and data acquisition. We'll learn about ZigBee Wireless technology, ZigBee Wireless-based Modbus data acquisition. If you have any questions at any time, please enter them into the chat box. I'm Maria Lamoni, our sales manager here at ICP USA, and I have Mohsen from our technical support department with me. Later in the training, he'll demonstrate how to collect data wirelessly with SCADA software. And if you have any questions, like I just mentioned, at any time, please enter them into the chat box and we'll answer all the questions at the end of the webinar. ICP was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP USA was launched in 2001 to support the North and South American markets. We work closely with our R&D department to add new features to products, develop new products, and to support our customers. We provide free technical support, and we can provide programming services if needed. For any orders over $200,000, programming and systems integration services are free. Wireless communication is the process of transferring information between two or more points that are not physically connected. Wireless networks help with implementing a clean installation in applications where physical cables are inconvenient, like in factories, buildings, and remote monitoring applications. They also help with mobile applications when working with moving vehicles and other kind of objects. This picture here shows a wireless RTD input module communicating temperature data back to a PC connected to a ZigBee host converter. Data acquisition is the process of sampling real-world information like temperature, pressure, motion, or tank levels, and the conversion of the samples into digital numeric values that computers and controllers can understand. This picture here shows a computer running a program on a PC. It's connected to an Ethernet switch, which is connected to an Ethernet-based thermocouple input and digital output module. The program takes the temperature data and triggers a fan to turn on or off based on the temperature determined by the thermocouple sensor. ZigBee is a wireless specification based on the IEEE 802.15.4 standard that operates over the 2.4 GHz band and was designed for creating networks with low data rates and uses small, low-powered radios. Its general-purpose, self-organizing mesh network for industrial control, data collection, building automation, and security systems. ZigBee wireless data acquisition devices are set up with dip switches. ZigBee host and slave converters are set up with a free software utility and can communicate up to 700 meters or 2,297 feet. You can test the wireless communication with the free software utility. Our devices follow the ZigBee Alliance standard, so they can be used with other vendors' ZigBee devices that also follow the ZigBee Alliance standard. Our ZigBee data acquisition products support Modbus RTU communications, so they can be used with Modbus RTU-based controllers and other equipment. Each ZigBee network has one RF channel and a PAN ID, so the devices can be in the same network. Each node has a unique node ID to differentiate each device from the others on the network. Each network has one host converter, which coordinates the communication path over the network. ZigBee networks have many slave converters. They can have many slave converters or slave I/O modules. Slave converters can be attached to various Modbus RTU or serial-based equipment, which can be interfaced with wirelessly to an embedded controller, PLC, or computer through the host converter. Slave converters act as a repeater and repeat the signal onto the next node in the network. In networks with multiple slave devices, if communication is unable to get through in the established communication path, it can reroute itself to an available path of communication. The host converter coordinates the communication path. You configure ZigBee host and slave converters with software utilities. You set the same RF channel and PAN ID information for all devices in the network. You give each device its own unique node ID. ZigBee host converters like ZT2550 have LED indicators that show ZigBee network communication, data transmission, and power. So you could see the green indicator indicates the network communication, the yellow one shows the data transmission, and the red one shows the power. So if there's ZigBee network communication, the green one will be on. If there's data transmission, the yellow one's going to be blinking, and the red one should be solid if it's on. You connect power and RS-485 connections through the removable terminal block. There is an RS-232 DB9 port on one side. You screw on the antenna to the SMA connector. We provide antennas that can extend the communication up to 2 kilometers or 1.2 miles. You can test ZigBee communication by connecting both the ZT2550 ZigBee host and the ZT2551 ZigBee slave converter to a host PC over RS-232 or RS-485 ports. If your computer doesn't have an RS-232 or RS-485 port, you can use a USB to RS-232-485 converter like our 7561 converters. You can use serial tools like Modbus Utility to test the communication. Modbus is a simple and standard, robust, serial-based communication protocol that's widely used for industrial communications for instrumentation, control, and data acquisition. Modbus RTU allows for communication between up to 255 devices in one network. It was originally published by Modicon in 1979 for use with its PLCs. Modicon is now Schneider Electric. Modbus is an open communication protocol that has been managed by the Modbus organization since 2004. It's openly published and royalty-free. Modbus is often used to connect a supervisory computer with RTU remote terminal units in SCADA supervisory control and data acquisition systems so you can see the status of equipment on a PC. It's also widely used in applications like energy management, machines, remote monitoring systems, wastewater processing systems, and building automation systems. Modbus applications are easy to deploy and maintain. Each Modbus device in a network is given a unique address. In serial Modbus RTU networks, only the node assigned as the master may initiate commands. In Ethernet-based Modbus TCP networks, any device can send out a Modbus command. One master device is usually configured to send Modbus commands. A Modbus command contains the unique Modbus address of the destination device. Only the destination device will act on the command, even though others might receive it. All Modbus commands contain checking information that ensures commands arrive intact. The basic Modbus commands can instruct an RTU to change a value in one of its registers, control or read an I/O port, as well as command a device to send back one or more values contained in its registers. ZigBee Wireless data acquisition modules communicate over Modbus RTU communication. Each module in a ZigBee network has the same RF channel and PAN ID. Each device has a unique node ID. Wireless ZigBee I/O modules can be used to turn lights on and off, or to turn motors or other equipment on or off. They can be used to monitor tank or pressure levels through 4 to 20 milliamp inputs and sensors. You can run free Easy Data Logger software on a computer connected to a host converter and can show the status of the I/O on a screen or trigger outputs based on inputs. ZigBee I/O pairing equipment like ZT2052 IOP has 8 isolated digital inputs. ZT2042 has 4 relay outputs and 4 digital outputs. ZT2052 IOP can be configured to trigger relay and digital outputs from ZT2042 based on its input. Since ZT2052 IOP has an embedded I/O pairing function, There's no need for any external controller in the application to implement the logic operations. The status of each digital input channel on ZT2052 IOP can be configured to trigger the corresponding remote digital output channels constantly based on the ZT2042 module. The ZT2052 IOP sends status updates of the digital input channels to the remote ZT2042 to ensure the digital output channels are synchronized. It comes with external dip and rotary switches for easy configuration. ZigBee Alliance-based modules with I/O pairing can be used to synchronize digital signals in any environment where wiring is inconvenient. ZT2052 IOP can be used in one-to-one configurations where each digital input on the ZT2052 IOP can trigger a digital output on a ZT2042. It can also be used in one-to-many configurations where each digital input on ZT2052 IOP can trigger outputs on up to 3 ZT2042 simultaneously. ZT2052 IOP has LED indicators that show the power status, communication status, and the status of digital inputs. It has dip switches that can be used for pairing number, PAN ID, and RF channel. There's a rotary switch that needs to be set to 0. On other I/O modules, this rotary switch could be changed for other settings, but for the I/O pairing module, it needs to be set to 0. This same switch on the ZT2042, for example, can be set from 1 to F in hexadecimal based on the number of I/O pairs. The PAN ID must be the same for all devices in the network, and also the RF channel must be the same for all devices in the network. ZigBee supports many flexible topologies like cluster, where nodes are arranged around the host converter in little bunches, mesh, where the host coordinator is at one end, or star, where the host coordinator is in the middle. Our ZigBee products are being used in food traceability systems for data collection and analysis of chickens, their weight over time. Chickens stroll around the coop, and each chicken has an RFID tag on its foot. As the chickens walk around, they randomly step on scales that are installed in the coop. The chicken's ID, birth date, and weight data is sent wirelessly from the chicken coop to a control center, which is 700 meters or 2,297 feet away. ZigBee data acquisition technology and our Modbus RTU-based power meters and controllers are being used in energy management systems. You can monitor and control systems based on real-time energy consumption through Modbus RTU-based power meters, power meter data logging controllers, and ZigBee Wireless converters, which helps to save energy. You can turn systems off based on conditions and can log data for analysis. The data is passed back to a SCADA system. Easy Data Logger is a control and monitoring software that can be used on a PC. It can be used to set up a small control and monitoring system so you can see the status of I/O, log data, see trend on a screen. If a PC is connected to a ZigBee host converter, Easy Data Logger software will be able to communicate with I/O modules that are connected to ZigBee slave converters or ZigBee I/O modules. Free Easy Data Logger supports up to 64 I/O tags and can send email alarms or SMS alarms based on conditions like when a temperature level is above a desired range. It can log data and show data on a trend graph over time. You can also use gauges and buttons to see a graphical representation of the data on the screen. It also supports one web camera in case you wanted to see live video footage of your actual application. An advanced version is available that supports more channels, more email alarms, and more web cameras. SCADA software can be used with wireless networks for more advanced applications that may need to support multiple users, generate reports, use recipes, and use animated graphics. SCADA software offers web publishing capabilities for remote access through a web browser. Different users of the SCADA software can have different permission levels and can also have access to different areas of the system. Administrator users, for example, could have access to make changes, and operator users could just see the status of the system. SCADA software can be used to generate customized reports, so you can configure the system with print buttons so you can print the customized reports out, or you can save them as a PDF. InduSoft supports multi-languages, so you can easily change the language in your system. I will now pass the presentation over to Mohsen for a demonstration of ZigBee data collection with SCADA software. And while he's getting it open, some of our company benefits, as I mentioned, include the free systems integration and programming assistance for large orders over 200,000. And we can also provide, we do provide free tech support. Okay, go ahead, Mohsen.
Hi, this is Mohsen from IC Plus Technical Support. Welcome back to InduSoft Web Studio presentation. What I have here is a pasted picture out of one of tech notes showing the tag database showing the driver. And it shows how we get information from PLC or other devices and it comes into our tag database. Actually, from outside world, tags are all internal, and where we get them information through the driver. Okay, I'm just using this as an example to talk about how the information gets in. Now, I'm going to open a project to show you how it is easy to get the data from over Modbus RTU into our SCADA system, which is InduSoft. And as Maria said, it doesn't matter if you receive this data through wireless, for example, from ZigBee or anything else. As long as it is Modbus RTU, it's very easy to get your data here. As an example, I have created a very simple screen here, and for add a driver in our Project Explorer, here there is a tab for communication, and here you can add drivers. If you just click on driver, you can insert your drivers, and as you can see, many drivers you have here. It could be a very specific driver based on a very special brand or product, or it could be general, like for example Modbus RTU. As you can see, I have selected here. Whatever you like, you can find it here, and you can just select it. Depending on the license you have, you can have multiple driver or only just single driver for your InduSoft Web Studio. And for this example, which I have created, I've used this Modbus Protocol RTU. And as you can see, if I go here, there is a main driver sheet for this driver. And here easily you can configure and set up your communication with the PLC or any other data which receives from out of the SCADA. Simply, I have created a very simple tag, which is a digital input. I have simulated here with one of our modules, which just to show you how easy it works. By the way, if you just click on this Modbus setting here, you can also modify and set up other configuration for your Modbus protocol. For example, to select the COM port, which you receive data in your PC, and baud rate, and different things. Okay, I go back to this screen. Here I have a very simple circle, and I'm going to show you how the color of this circle can be changed by the data which we receive through Modbus RTU. And here also we can see the value changes. I'm going to run it here to go to the runtime. Okay, I just simulate, and as you can see, the color is green when this input, digital input signal is 1, and when I turn it off, the color will go back to red, as you can see. And if I go back to the development here, again, I will turn the digital input on, and as you can see, the value is changed to 1, and when I turn it off, the value is going back to 0. And this is the tag which I created. If I go back to the main driver sheet, you can see it's very easy to configure this communication. In this table, I just put the tag name. This is the station address of your remote I/O device or Modbus slave, and this is the I/O address. And because this is digital input, the I/O address would be 1x column 1. This is, for example, digital input, the address 1 in your Modbus registers, and you can just read it. And for creating a tag, here, if you just go to the Project Explorer in the global tab, here you can easily create it what you like. And for example, this is the tag which I have created before, Modbus digital input 0, which shows the channel 0 of our digital input module. You can easily insert more tags, and it could be integer, boolean, real, string. And here in main driver sheet, you can easily connect them to your Modbus network and receive data from PLC or any devices outside. Okay, I pass to Maria. If you have any question, I will be happy to answer, and thank you very much for your interest in the soft.
Okay, so Tom has a question about pairing two modules without a master. So yes, you could do just one ZT2052 IOP with a ZT2042. You could just pair those two together and you wouldn't need any host device. Another question, how does one configure a slave mode? Mohsen, do you want to answer that one?
Slave mode where? In the Modbus network?
Not sure. He didn't say, but he did ask about how a ZigBee master is configured. Tom, are you asking about how to configure a slave mode in Modbus in general or in ZigBee in general? Or maybe you can talk about both, Mohsen.
Actually, when you have a network, our ZigBee would be part of our network. It means the whole network is a Modbus network, and you have a master, and you have some slaves. And what ZigBee will do is just to provide us some a wireless communication. And this is the general setting and general configuration which you do for slaves and master in Modbus network. And but here you need to consider that you have ZigBee as well as a part of your network, and it has one host and then some slave, maybe one slave in your ZigBee network as well.
Okay, so he's asking in particular about ZigBee slave mode. So there's different kinds of application modes, like there's addressable mode, when it's like an advanced mode where you only transmit data to the specific ZigBee slaves from the host. Because, for example, if you had a really large application where there was a lot of ZigBee modules, you may not want to transmit the data out to everybody, every module in the network. You might only want to give the data to that one node. There's also transparent mode where the data's, it's like broadcasting, where the data goes out to everybody, every node on the network. And then Okay, so he's saying how to configure a ZigBee slave module. Okay, so for example, the ZigBee I/O that we showed earlier, that is a ZigBee I/O that has the dip switches. So that would be how you configure it with the PAN ID. Let me pull the slides back again. This slide here shows you how to configure one of the slave modules. These are the dip switches. So if you're pairing with one module, you would if say only one module, you would just move one of these switches up, and then this is to set the ZigBee PAN ID and the ZigBee channel. And then that's it, actually. The ZT2551 is a slave converter. Let me pull that up.
Oh, and Maria, the rotary switch is for the Modbus address, the most significant bit.
Okay, do you want me to switch to you to be the presenter, Robert, so you can show how to configure slave modules?
But let's see, for ZT2555 or ZT2551 and ZT2571, those are ZigBee slave modules. You connect with the utility via COM port or Ethernet if you have the 2571 with the utility to set the PAN ID and the node ID and the address of the module, and then from there, once it's configured, you can connect it to the host. You would set it for the same channel ID.
Right. So if your slave devices, if they were say like some sort of a ZigBee, like some sort of I/O module other than the ZigBee modules, ZigBee I/O modules. Tom's asking, how does the Modbus master know the Modbus slave over ZigBee? And that has to do with the what I was talking about a little while ago about addressable or transparent modes, communication modes. So if you set it up where you're using transparent mode, the information is going to be broadcast out to everybody. But I think in particular, Robert, I think he wants to know how to set it up.
Okay, I think I understand his question. I think what he's talking about is he thinks that the ZT2551 is a Modbus slave device. It is not a slave device. The ZT2551 connects with Modbus RTU slaves via the RS-45 bus. So the individual slaves will have their own specific address, but the ZT2551 doesn't have a specific Modbus address. It is just a means of communicating to the slave devices connected to the RS-45 bus.
Does that answer your question, Tom? So basically the ZigBee host, like a ZT2550, and the ZigBee slave converter are set up with a software utility. So you set it up on your computer with the software utility where you configure your COM port, and then you configure the RF channel, the PAN ID, and then the node ID. And then after that, you test the communication, and then after that, in your application, it's kind of just like it's a COM port. Is that right, Robert?
I tend to think of it more as like a wire, but yes, do open it as a COM port connection, and you can communicate to your other devices at the other end.
Okay, so describe the COM port configuration using USB. So for this particular module ZT2551, it doesn't have a USB port. So when I mentioned the 7561 type converters, these have a USB port which you can connect to your computer. And then they also have RS-232, RS-485, and RS-422 type ports on the bottom. So you could plug one end into your computer with the USB port and then use RS-485 or RS-232 type wiring to go to your serial device. So this is the kind of device you would use to connect your computer to the ZT2550 or 2551, for example.
Okay, Maria, we also have the ZT USB if the customer doesn't have, I believe it's 60-meter range.
Right. So we have this that you can plug into your computer's USB port if you want to just use your computer or your device to communicate as a ZigBee master.
It would take the place of ZT2550 or 2570.
Any other questions? Okay, well, you can always contact us at any time. And thank you so much for coming to the training on ZigBee data acquisition. And I'm also going to email you the slides so that way you can have them. Thank you.